All right, in this next series of videos here, we're going to talk about another rigid motion, which is called a rotation. You guys were telling me last time that maybe you've studied rotations a little bit, but this is going to be kind of a spin or a turn, okay? And it's going to be a turn around a specific point, which we'll discuss again in a second. But for now, let's maybe look back at an example of one of the other rigid motions that we talked about, which is a translation, okay? And this one says the translation image of P, which is -3, -1, is P prime, which is 1 and +3. So it says find the translation of image Q. Okay, and so we're really looking for what's going on with the pre-image to the image. All right, and we can just kind of take a look at what actually happened from our pre-image to our image in P. Right, so you can just kind of write both of these down, maybe copy it again. Right, our pre-image for point P was -3, -1, and somehow we got to P prime, which is 1 and 3. Okay. Now remember, this is just kind of a slide along a vector, right? And so we're just sort of looking what happens here, right? So how did we get from -3 to +1? Well, it looks like you'd have to move 4 spaces to the right. Okay, so I'm just going to write that down. Move 4 spaces right. Okay, and now I guess we can look at, what happened, how did we get from -1 to +3? Well, you'd have to move 4 spaces up for that to happen. Right? So let's say, again, move 4 spaces up. Okay, and so really if we take, again, this pre-image of Q now, and we follow those rules that we just stated, we're going to move 4 spaces to the right and 4 spaces up. So that would mean that Q prime, or the point Q in our image, is just going to be the point 6, and -4 + 4 would be 0. Okay, and so there is Q prime there, okay, our image for Q. Okay, and so today, again, we're going to try to identify and draw rotations. Again, this will be maybe a shortened version of a usual lesson. We'll go through kind of some specific examples in the coordinate plane. Okay, so this kind of just gives us a good definition for rotations, and again, this is in your notes, but it's just going to be a transformation that turns a figure around a fixed point, and that fixed point is just going to be called the center of the rotation. Okay, and so it also, again, reminds us that a rotation is a rigid motion of the image, and so the image of the rotated figure is congruent to the pre-image. Okay, so just like the image was congruent to the pre-image in translations and reflections, it's going to be the exact same thing for rotations. All right, so let's just look at a couple examples here. Very simple. It asks us to tell whether each transformation appears to be a rotation and then explain. All right, well, we want to see if we look at, for part A, we have kind of this like messed up looking star from red to blue. It doesn't really look like this turns around a fixed point. In fact, it looks like it kind of is reflected about this vertical line here. So I would say no on this particular one, and maybe just say that our object appears to flip. And so that would be a reflection, not a rotation. Okay, and on part B, it looks like it does actually rotate around a fixed point here. If we look at this point right here, it looks like everything kind of swivels around and turns around this one point. And so for part B, we would definitely say yes, and we could say something like, object appears to turn around a fixed point. Okay, so let's maybe just look at a couple other examples and make sure we're able to identify when an object is being rotated. Okay, so in part A, we look at this. It seems to kind of share a point here. So to maybe start it, says, maybe this is, right? But if we turned this, it looked like it'd be 180 degrees, our image would actually look something like this if it was a true rotation, right? For this one, it looks more like a translation. So we can again say object appears to slide, right? And so this would be an example of a translation. So again, I guess our answer would be no. And so that one appears to be a translation. Okay, on this last one, again, we have this kind of shared point here, and it looks like everything does kind of, match up here. It looks like we're kind of turning this way or you know, we could actually rotate it counterclockwise, which we'll maybe get more into that in a second. But yes, I mean, this does appear to be a rotation. Okay, we can say just that the object appears to turn around a fixed point. Fixed point meaning, again, does not actually move. Okay? All right, so perfect. In the next few examples, we'll take a look at some rotations in the coordinate plane and just discuss the important rules that exist when we perform rotations.